speaker or topic is Impactful Resilient Infrastructure, Science and Engineering by Dr. Julie Vandenbossche, PE. Julie has, since 2002, been a professor of civil engineering at the University of Pittsburgh, teaching, conducting research, and performing services in the areas of concrete materials and the design, analysis, and rehabilitation of concrete pavements. Prior to this, she spent 5 years conducting research for the Minnesota Department of Transportation at their Minroads pavement testing facility. Julie earned her BS and MS degrees from Michigan State and her PhD from the University of Minnesota. And I know, working with Julie for the last couple of years, she does a lot of work that's very good, and she is able to take research and actually put it into practice, practical practice.
Thank you very much. First, I'd like to thank John Becker and everybody for allowing me to come here today. Always nice to follow Jim Mack up. Great presentation, Jim. And for those of you that did enjoy Jim's presentation, his favorite drink is a Prairie Fire, so be sure to grab one for him this evening to thank him for all that hard work and effort and the great presentation. Today, though, I'm going to be talking about IRISE. And IRISE is a... Here we go. An initiative that we're starting at the University of Pittsburgh, and as was previously mentioned, the acronym IRISE stands for Impactful Resilient Infrastructure, Science and Engineering, and it's a cooperative research consortium that we're putting together to focus on just immediate solutions leading to more durable, longer-lasting infrastructure, kind of in line with what Jim was talking about just prior to me coming up here. And the unique thing about IRISE is that it's getting everybody involved that has an impact in what goes on in trying to make our infrastructure more durable and longer lasting. So trying to get the public, private sector along together with academia to solve some of the issues that is identified jointly together. And as there's a lot of conversation going on, why is there a need for IRISE? And as you're hearing, we're looking at performance, and the infrastructure, is in need of rehab. It's aging, and we need to be proactive in addressing these problems. The infrastructure itself is governing the economy and, the vitality of the economy, the quality of life. And these pictures down here, when I'm in Pittsburgh, I say these pictures are from Philly. But then when I'm in Philly, I say these pictures are infrastructure in Pittsburgh. So now in Harrisburg, I can say the one on the left is from Pittsburgh, the one on the right was actually from Philly. But really, this is a problem. It doesn't matter where you are within Pennsylvania or around the country. Infrastructure definitely needs some care in trying to get it back to where it was. As we talk about the cost and how much money we're spending, it's relatively flat, but the infrastructure itself, the needs are just continuing to increase. And so if we're just going to have relatively flat funding, how do we meet these needs and get ahead of the situation? And so what we want to try to do is through, obviously better engineering and better solutions to the problems. And so with IRISE, what we're trying to do is take a systems approach. And we're looking at, not each of these individual domains, if you will, the pavements, the bridges, the retaining walls, but the system itself and how we upgrade and maintain and address the system itself and the interaction between the components. So with that, then we obviously have the different components that will feed into trying to improve this system. Evaluation, whether it's through sensors or non-destructive testing, or we're good at generating data, but we want to make sure that we have quality data. We're now really getting to the point where we can, we have a lot of tools in machine learning and analyzing big data sets, But again, the quality of the data is important. Not just a lot of data, but quality data. So collecting data, managing data, and using this to look at the systems and how can we better engineer, how can we use better materials. And so putting all this together, and again, looking at it as a system, as a vote, opposed to each of these little individual domains that we have. So why is IRISE different? There's a lot of centers and consortiums around the country. What makes IRISE special and unique? And I really appreciated the introduction because I came from a DOT, as was mentioned, and there I was in the research office. And one of the things that I learned is that to really have impactful research, you have to get all the right parties involved. And that's the people that are constructing, that's the industry, it's the people that are designing, it's the materials people. So getting all these people together and talking and working together to solve the issues is really important. And this comes from a research perspective if what you're looking at is going to be meaningful and actually a problem instead of something that's identified up in our ivory towers in academia, but a real issue that people are facing and a challenge people are facing, then that's the first step. So getting everybody together and talking and having each of these separate entities, everybody plays a role, and it makes it a lot more fruitful, and getting the results in an impactful manner is a lot more, it's more readily achievable. So that's the big difference. And when you apply this to research itself, and I had mentioned first, clearly identifying a problem, when you get the designers and the constructors, the industry and everybody involved, and just having good dialogue is kind of the first step. But then trying to, once you do identify an issue that needs to be addressed, identifying an approach that is actually addressing the problems in a manner that can be implemented sort of trickles down. So then executing the research, and again, making sure that the research is executed in a manner that is going to produce results that can be implemented while still addressing the actual problem that was identified. So once you do have something that's meaningful coming out of the process, how do you get it implemented in so that it's actually used? And, in doing that, having people there early on and throughout the whole process makes it a lot easier to get it implemented. There's better buy-in because everybody contributed along the way to make sure that what was being addressed was an actual problem, and the manner in which it was addressed was actually providing a useful solution. So this is kind of the approach that I think is really unique in IRISE, just having all these partners sitting down together and talking about these issues and working through them together. So the next thing that I think is different about IRISE is the systems approach that we're taking. So again, we have a lot of times within our specific domains, pavements, for example, we talk about pavements all the time. Yet we have bridges that are in the same, the same infrastructure and directly adjacent to our pavements, but getting communication between those and how they interact together so that we can work at things in a more efficient manner. If we're out addressing a bridge and there's problems in the pavement right next to it, why aren't we tying it together? So again, going back to the system approach, working across domains, looking at the life cycle of both from the economic point of view and sustainability point of view. And then again, the big emphasis is implementable results. So I discussed a lot about the research aspect of it, and there's other components to it that I think are useful. Again, I think some of the things that had helped me throughout the career, I want to bring back through IRISE. When I was with the DOT, I was able to go out to the sites, whether it was in the concrete office, and the concrete engineer would take me out to the plants, the concrete plants, and let me know, this is what you need to look for. This is how you get consistency between mixes. These are problems that can occur. Or if you're out on a paving site, the same type of thing. So being able to look at things out in the field and then incorporate that into what I was learning on the research side and in the classroom, I think that helps with students as well. So communication between all these parties, education with respect to both the undergraduate and the graduate students. We have a lot of students here from the University of Pittsburgh, some of which have graduated and worked for PennDOT and other agencies. But I think that, they probably didn't come to the University of Pittsburgh thinking I'm going to, look at pavements or specific aspects of pavements, but they've had the opportunity to do undergraduate education or research at the graduate level, and they kind of get sucked in, and they have the opportunity to meet people like you to give perspective to what they're doing. So having them being able to have access to you and you have access to them, I think is another benefit of IRISE. An additional component I think that's really helpful, with respect to communication, in bringing what you do out in industry and in the field into the classroom is helpful from both sides too. So when they graduate, they know where they can go and look for jobs. They know what you're looking for, and also you're able to identify future employees. So with that, even with what we're doing now with some of the partners, for example, they were talking about the Southern Beltway. So how is their interaction there? I worked with the Turnpike to give me data so that the design for the pavement design class was actually designing a portion of the Southern Beltway. And then we took the students out to the Southern Beltway and looked at the paving projects thanks to Golden Triangle and the Turnpike. So we have a lot of opportunities to work together, and I think it really helps benefit the students. But at the same time, for pavement rehab or other classes, then I can go to these agencies and get data. And maybe it's data that they've been struggling with a little bit, but we can take it and use it in the classroom and also give them feedback on results. So it gives students good actual data and interaction between what's being taught in the classroom and also industry and the public agencies as well. So who's doing the research that's identified through IRISE? Again, IRISE is out of the Civil and Environmental Engineering department at the University of Pittsburgh, but we also work with other departments within the Swanson School of Engineering, mechanical, chemical, as I'll mention in a few minutes, as well as other areas within the University of Pittsburgh. So, in computer science, we're working with big data. It's nice to have access to the people that are using these tools all the time, whether it's public policy in the GISPIA department, all of the different entities within the University of Pittsburgh that are helpful in providing the tools that we need to address the research identified under IRISE. Another group of that is the Mosquero Center for Sustainability. They've been active looking at doing joint projects with them, so partially funded by IRISE and partially funded by them. And so all of this is done under the guidance of the steering committee, which we'll talk about in a few seconds. But also we draw upon the experts, across the state, across the country, as well as within the specific partners that we have with IRISE. So the consortium itself and sustaining that, our current partners are Allegheny County, the Turnpike, PennDOT is a partner. Golden Triangle was one of the first public, they were the first public partner, which I think speaks volumes for how progressive the paving industry is. Michael Baker is also a partner. We're working with Dan Cessna with Michael Baker. And we're looking for new partners as well to kind of grow this. This just started this past fall. So we just started initiating contracts and getting research going. As far as growing it in the future, new public and private partners. We're looking for partnerships with other universities as well, and also to link this in with UTCs, and NSF also has funding for public-private partnerships. So we're just getting started, looking for opportunities to grow. Things, again, just kind of initiated this past fall, but we have good momentum, and I'm pretty excited about where we're going. So how is the research that's performed under IRISE initiated? And this all starts out with the steering committee. So all of the partners are on the steering committee, have representation on the steering committee, and they approve the final program. The whole process takes about a year long, and it starts off in the fall with a brainstorming session. This was something that we based off what we had previously done with PennDOT, and it's a really great activity, and it's sort of the core of what IRISE is all about. So what we would do is meet with the districts near the University of Pittsburgh and talk about some of the issues that they have been having, and a little bit about our skill set at the University of Pittsburgh to kind of see what their needs are and how we might help address them with the expertise that we have there. And I think that, you know, again, this was kind of where everything started, in the sense that just getting the different districts together, and, you know, one district might say, well, yeah, we had the same problem and we address it this way. And then, you know, somebody at the university might say, well, yeah, but we also heard about, you know, this group over in Minnesota or Iowa, and they look at it in this manner. So just getting the communication and the dialogue really helped, I think, both in the field where they're actually doing things, but also in academia as well, because then that kind of keeps us tied to what's really going on, so that when we are looking at research, we're looking at actual problems that they're trying to address in the field, and when we're trying to solve these issues, our solutions are something that can actually be implemented. So it started off with that, but now we also have you know, the industry that's involved. So we have a lot more people at the table, which again gives you a lot more information with respect to how other people are addressing similar issues, and also a lot more dialogue with respect to, you know, a lot of what happens is typically if there's an issue, it's not usually one component, but how the design and the materials and the construction might have interacted to create an issue. So here you have all the people at the table. You have materials people, you have the designers, you have the agency that's overseeing it, and you also have the contractors. So getting this together and everybody in the same room, I think just the communication itself helps solve a lot of issues. So this, in the brainstorming session, we get everybody together. Since this was our first one this past fall, what we did was just invited anybody. You didn't have to be a member. Anybody welcome. Everybody was welcome. We had a lot of great discussion. It went for a whole day. Through that, we developed some of the problem areas that everybody thought needed additional work, or areas that needed to be addressed. And with that, we come up with a work program. So since this was our first year, we're just kind of getting the funding going and into the system. It was sort of accelerated. So we have 3 projects that were identified early on. More partners have been joining, and we are going to try to finish out the work program for the 18-19 year with a couple more additional projects, as I'll talk about in a second. But then we'll use that to develop the work program for the 19-20 year. And every May, we're also going to have an annual meeting. There we'll discuss with the steering committee the program and establish what's going to be going on for the next work program year. Projects will then be initiated in August, and again, that works within the academic system, but also kind of provides us with the complete cycle. So what projects have been identified so far? We currently have 3 projects that are underway. I'll discuss them briefly here. The first project is being completed by Dr. Max Stevens. He's a new faculty member that has just joined the university recently, and he does a lot of work in the bridge area, a lot of concrete work too. But he's working with Dr. Brian Gleason in the mechanical engineering department, who does a lot of work on corrosion. So with this particular project, they're looking at new novel ideas where they can address both corrosion prevention as well as methods and technologies for mitigation. I guess the first thing is you could just cover it with concrete, right, or make a concrete bridge. I'll suggest that to them as one of their options. But there are a lot of things that have been done historically with respect to this, right? This is not something that's just popped up. We've been dealing with this for a lot of years. So looking a little bit about what has been done in the past, you know, so we don't repeat it in the future, but then also technologies that are looking like they might have potential, maybe not adopted on a wide scale yet, but look like they might have some value. So they're looking at it on several aspects. You know, obviously environmental regulations are always a concern. Health protection, cost reduction, coating performance, so the performance and the viability of the technology, and of course sustainability, which again matches a lot of the themes that we talked about that IRISE is centered around. So they're working with major paint manufacturers, again, the people that actually produce material, to make sure that anything that is developed is actually something that is implementable. And they're going to look at different approaches and what might be the most effective. Something that might be of higher interest to this audience, they're looking at, well, I'm a partner within this, material compatible repairs for pavement and bridge rehabilitation. Again, that goes back to looking at things as a system. We obviously do repairs on pavements, but obviously, you know, we have concrete bridges that need repairs as well. So does one fix all? No, but from a basic level, the needs can be similar. With respect to what do we need to get longevity out of that repair? And, you know, we want strength, durability, but we also want the repair material to deform in a similar manner to the existing material, so that you have, you know, once you have compatibility, and again, that's the material compatible repair component of it, then you don't have the debonding of the repair material away from the existing pavement. So what these needs are in a bridge are different than what they are in a pavement. And even within a pavement, if you're doing a partial depth repair versus a full depth repair, what you need out of that material is different. So not just using concrete to do the repair, but actually looking at the concrete material and designing the material to make sure that the repair material is compatible with the existing. So in doing that, we're looking at strength. How can we get additional strength? Internal curing is a good component for that. Durability. The structure and, you know, repair deforming at the same load. So if you stress it, if the stiffnesses of the material are similar, they're going to deform in a similar manner. That's beneficial. If you look at changes in temperature, if they're going to deform the same, contract, or expand at the same rate when you have changes in temperature, that's going to decrease the stresses along that bond. So that will be beneficial. And by doing that, we'll look at similar stiffnesses or Young's modulus, similar thermal coefficients of expansion, and then, of course, drying shrinkage, which I can't seem to spell correctly, is also a component of that and something that can be addressed through internal curing. So Caitlin is the graduate student working on this particular project. So if you can go by and talk to her and visit, she has a poster up here and can talk more about that. And again, a component of this to try to help the strength and reduce the drying shrinkage is internal curing. And we've done a little bit about with this regionally, but there's more I think we can do. And I think when we apply this to repair materials, it can really be extremely beneficial. You know, you typically have the surface to volume ratio really kind of plays a role. It makes drying shrinkage much more problematic than it might otherwise. So this can help with that, and also, you know, the great need for a good bond strength, and it can be beneficial for that. So how many people have heard of internal curing before? Okay, so as half of you know, you're feeding moisture into the cement grains so that you can make sure that they're hydrated appropriately, especially if you're going to use the low water to cement ratios that can provide us with the bond strength that we like. Again, Caitlin can give you a lot more information about this. So the idea then, of course, is how do you feed this internal curing within the system? What are you using? And there's a lot of different types of materials that can be used. And again, a lot of times what we're looking at with respect to internal curing is looking at reducing the drying shrinkage, increasing the strength. But we want to take a different spin on it and make sure that these are material compatible repairs, as we were saying. And the drying shrinkage and strength is just a component of it. But if we can get thermal coefficient of expansions that are equivalent, so they're deforming the same when we get changes in temperature of the structure, and also similar stiffnesses, then that's a targeted goal for what we have for these repair materials. And then the other thing that would be of interest to this audience would be what Dr. Kazanovich is doing, and I think he's out fighting the snowstorm right now, trying to get back to Pittsburgh to teach class. But what he's working on is a design tool for rigid pavements. They did something similar in Minnesota, and the idea is that if you can have a tool that provides you with the same outputs that you would get if you're using Pavement ME, but made it a simpler, easier tool. How many people have used Pavement ME? So not a lot. And if this tool comes out quickly, you may never have to, so that would be a good thing. Now the thing is, it's very cumbersome. There's a lot of inputs, and it can look at a very diverse cross-section of pavements. But, you know, the idea with, you know, if you're just looking at materials that are used within Pennsylvania that are in 408, you know, do you really need to see this big library of materials? If your traffic characterization is similar to what we have in Pennsylvania, do you really need to know what everybody across the country is doing? So if we can limit these inputs and make this a much more simpler tool that's easier to use, then that's advantageous. The other thing is that we wouldn't have the really high cost that's associated with the license for Pavement ME. So this is a snapshot of what Lev has developed for Minnesota. But then you can kind of see there's just a couple of simple pages that you're entering in data, so it can greatly reduce the time it takes to develop a design, yet you can still you look at the full range or gamut of materials and inputs that would be suitable for Pennsylvania conditions. So this would be hopefully beneficial to the Turnpike. I just saw Allegheny County is also a member, as well as PennDOT, and you know, Allegheny County, of course, they're not really interested in buying a big license for Pavement ME. But again, if you can have the same power of that tool and this simplified, easy tool to use, then that would be great. So the idea, again, is just the systems approach. I just have these projects on there showing us where it fits within the whole IRISE scheme. And, you know, we have materials-related issues, corrosion, also the decision-making with the design tool. But again, we're just getting started. Hopefully we'll have a couple more projects coming up shortly, and then the full work program starting up in the 1920 fiscal year. So as I had mentioned, a couple more additional projects for this program. We had the fall brainstorming session last fall. A lot of the districts were represented out there, as well as central office. And we're using that to compile a list of projects that came out of that brainstorming session that the partners were interested in to give to the steering committee for selection and these projects will initiate in August. So, why support IRISE? Again, I think that the whole idea of having this collaborative effort and getting everybody together at the same table, is in academia we kind of have this, we have to publish, and everything's about numbers, right? How many publications? How many expenditures? How many grad students do you have? But really, at the end, the idea is not to just come out with all these numbers, but to have research that really has an impact. And, I think that with IRISE, it's not just research, but it's the dialogue, it's the opportunities that it presents students, it's the interaction between, students, employees, and, whether it's through research opportunities or, just the ability to communicate, regarding, I'm working on this project. Great, that's a great design project for the class. And if we're giving the class projects that are directly from what you're doing, then when they come out and work for you, they'll have a better idea of what they're doing. Giving the students access to the sites. A lot of the contractors have been great with, providing us at the University of Pittsburgh these opportunities. And, we do it a lot in the pavements area, which I've been really grateful for, and I hope we can expand on it and bring that throughout our department. So with that, again, the employees also get access to the students and outreaching to them. So hopefully it's an advantage to both the partners as well as the students. And we also, I think just by developing this network and opening up this communication, if I have an issue when I'm doing research and I'm trying to do something, I know who I can call to find out whether what I'm doing is really a half-cooked idea or something that can actually be used and implemented in the field. And so providing this network gives me access to that knowledge, but then also, the people, the partners, access to the knowledge at the university. So they have people that they can call about specific issues, whether it be locally or around the country, and how they can address those specific issues. So good communication, access both ways, and we're really excited about what's going on at Pittsburgh with IRISE, and hopefully with this presentation I got you a little bit excited about it too. So with that, thank you for your time. Originally, I was going to go 45 minutes. I split the additional half hour that we were going to use with Kurt because Larry didn't show up, but everybody but Kurt and I in the room were happy that Larry showed up. So with that, I'll end, but thanks again for your time.